Thank you. I realized when I started to put together my slides for this talk that I had a lot more things than I could actually say in the 40 minutes that we have today. So this is going to be a fairly brief introduction to this whole topic of database corruption. It's one that I actually run into a lot because when you work for a PostgreSQL company, as I do, people tend to come to you with when they have a serious problem. And sometimes when they have a really serious problem, somebody at Enterprise DB asks me to take a look at it. And so when I went back through my email, I found that I had tons of different cases of corruption that I've interacted with different customers about over the years. And there's so much interesting stuff that we could say about this topic, but we're going to have to keep it short today because of the limitation of the time. So I'm going to start by giving a little bit of a definition of corruption. It may seem kind of obvious, but I feel like it's easier to have a conversation about any topic if we're all sure that we know exactly what it is that we're actually talking about. I'm going to give a quick overview also of the three main causes of corruption, just very broadly speaking. Then I'm going to spend some time talking about some best practices that you should deploy in your environment so that you avoid corruption as much as possible, and so that if it does happen, you will detect it as quickly as possible. Then I'm going to show you, tell you a little bit about signs of trouble and actually show you some examples of messages that you might get if your database is corrupted. And finally, I'm going to talk a little bit about some things that you can do in order to try to recover from the situation or try to recover at least some of your data if corruption does happen to you. I'm always a little afraid when I give talks like this that people will get the impression that corruption in PostgreSQL happens all the time, and I think that's basically not true. But as I said, it does happen to me all of the time because the problems filter toward me on those rare occasions when they do happen. So none of this is intended in any way as a knock on the reliability of PostgreSQL, and I think most people do have a good experience with it, but there are definitely things that you should do to protect yourself. I'm not sure how we're going to do on time. Feel free to raise your hand and ask a question if something's not clear or you need a further clarification, but I probably won't be able to take too many questions or we will overrun the allocated time. So let's start by trying to define what we mean by corruption. So the best definition that I could come up with is corruption is when the database queries behave in a manner that is severely unexpected given the SQL statements that have previously executed. Our expectation of a database is that if you put your data into a database, you're going to be able to get the same data back out of the database, right? Unless there's some reason. Obviously, if you put the data in the database and then you modify it, what you're going to get back out of the database is the modified data, not the original data, we hope, right? If you modified the data and it was actually changed, and then somehow it went back to being the way that it was before, that also would be corruption, right? We're really talking about, when we talk about corruption, we're really talking about things that could make the database perform in a way that is not expected, given our ideas about what the SQL statements involved are actually supposed to do. And I think there's basically two kinds of corruption, two sort of things that happen when corruption occurs. One is we might put some data into the database, and then when we try to get it back out, we get different data than what we originally stored. That would obviously be very bad, and that would be corruption. The other thing that might happen is that we might not be able to get our data out of the database at all. We could try to access our data and get some kind of an error or crash or other misbehavior that tells us actually your data is no longer accessible. And that would also represent database corruption, or perhaps some bug, but for this talk we're going to focus on the corruption case. So how can this happen? Basically, there are three ways that your database can become corrupted. The first is that you might have bad hardware. For example, you might have a bad disk. Or, and we have seen actual examples of this, you might have bad memory that corrupts the data before it ever even reaches your disk. You might also have bad software. You could have bugs in PostgreSQL, or in your operating system kernel, or in your virtualization layer, or in your file system code. Okay, so if you have a bug in any piece of software that is interacting with your database in any way, whether it is the database software itself or something else, then that could potentially result in corruption. And I think we probably know from experience that all software has bugs. All software has bugs. And the third way your database can be corrupted is user error. One that I have seen very, very commonly is faulty backup and recovery procedures. I'll talk a little bit more about that further into the presentation. So you might say, well, if you look at these three causes, generally speaking, which one causes the most problems? It's close. They all come up pretty regularly. I would say the third one is the most common. More people hose their own database than get hosed by their software or by their hardware. So that's why it's really important to follow best practices for how you manage the data in your database. It is, after all, critical data. And if you are responsible for that database, you need to put in the time and the energy to make sure that you're taking care of your data in an appropriate manner. I've divided the best practices that I want to talk about up into basically 4 categories: backup and restore, configuration, storage, and then administration. So let's start with backup and restore. Here I'm going to say something that all of you have probably heard at some point in some other talk. Please take backups. Take them regularly. There are 2 reasons why this is really important from the point of view of corruption. Maybe the most obvious one is that if you do experience database corruption and you have a backup, then you could try to get back the data that you lost from your backup. And then you wouldn't actually lose data after all. The other reason why this is really important is that it proves that all of the data blocks in your database can still be read off of the disk. And that's not something that you should take for granted. Disks fail. Disks fail, again, from my perspective, pretty frequently. Even very, very expensive disks that customers say, this disk will not fail because I paid a lot of money for it. Well, yeah, it still does sometimes. So if you can take a backup and it doesn't hang with an I/O error or anything like that, you don't know that you've still got the original data that you intended to store, but you at least know that something is still readable off that disk, and that's a pretty good thing to know. Along with this, of course, it's not enough to take the backup. You also need to make sure that you can restore the backup. Otherwise, the backup is of very little use to you. And you should really verify that the restored backup looks okay. I mean, if you just run the backup restore script and it spits out a bunch of files, and you don't do anything with those files, you don't check whether your data is there, you don't check whether you can run queries against the restored database, then you don't know for sure that that's going to work. So take backups, do test restores, verify that the restored backups look okay. And right there, just doing that much, you will be much more likely to notice if some kind of database corruption has occurred, and you will have some options for getting your data back. The other piece of advice I have about this, and this is probably the most important piece of advice on the slide, except for the idea that you should take backups at all, is use a good backup tool, not some homegrown script that you created yourself. A lot of people don't do this, and it often works out rather poorly in my experience. Sometimes people don't read the directions that are in the documentation. Sometimes they read them, but they miss something. Sometimes they forget about having error checks in their backup script. It's a very good idea to have error checks in your backup script. Using a professionally written tool does not guarantee that there will be no bugs, because I think probably all the professionally written tools have had some bugs too, but it means that somebody is putting a lot more time and effort into that tool than you can probably put into your tool, and ideally that person is more of an expert in regards to PostgreSQL than you are yourself. So I'm not going to get into the business of recommending one tool over the other. There's the internet for that. You can form your own conclusions. There are several good tools out there, but really consider using one of them rather than relying on your own scripting ability. Okay, configuration. This is an area where there's not too many settings that you need to configure, but there are some, and they really have an impact on the reliability of your database in the event that you have an operating system crash. There are really 3 settings in PostgreSQL.conf that you need to be aware of. The first one is fsync, the second one is full page writes, and the third one is wall sync method. For fsync and full page writes, the rule is very simple. They should be on. They should be on all the time on every PostgreSQL installation. I mean, obviously people are going to do other things. Sometimes people turn fsync off during an initial load, and then they say, well, I'm going to turn it back on afterwards, so it'll be fine. And they're right, except they forget. And then 2 years later, they have a database crash, and oops, they have a corrupted database. So was the time that you saved on that initial load of the database by turning fsync off really enough to compensate you for the fact that 2 years down the road or 6 months down the road or whatever, you have a corrupted database? I would guess that for most people, it's not. Similarly, full page writes, this is one thing where many people think they're very clever. They read the description of full page writes in the documentation, and they say, oh, I can set up my system in such a way that I will be able to safely turn off full page writes without compromising the reliability of the database. All of those people are wrong. At least all of the ones that I've met and had a conversation with about this have been wrong. Don't turn full page writes off. You will get a corrupted database if you have an operating system crash. You need to use a safe value for wall sync method as well. Unfortunately, some of the operating system specific defaults seem not actually to be safe settings. On Mac OS X, you can't use the default setting, which is fsync. You have to use fsync write through. I am not a Windows expert, but I've been told that on Windows, you either need to use fsync or fsync write through or disable the write caching on your drive. If you don't do this and you have an operating system cache, you may end up with a corrupted database. My general advice here is check the output of the pgtest fsync utility, which is included in every PostgreSQL installation, and see whether your wall sync method, the one that you are using on your system, is running like 10 times faster than some of the others. If it is, it probably doesn't really work, right? Because the fastest way to, the wall sync method is measuring the method we use to be sure that the data is all on disk. And of course, everybody wants that to be fast. But if it's too fast, if it's unrealistically fast, it probably means that somebody's lying. And unfortunately, my experience has been that although things have gotten better in this area over the years, there are still a lot of operating systems, a lot of file systems, a lot of device drivers for individual types of hard drives that lie and claim that the data is securely on disk when it actually isn't. That is a critical issue for PostgreSQL, so check your wall sync method. Another really good idea if you're concerned about corruption is to run with checksums enabled. To do this, when you initially create your database cluster using initdb, you need to use the -k option. This will not prevent your database from becoming corrupted. It will not magically recover your database if it does become corrupted, but it does greatly increase the chances that you will know that your database has become corrupted, because when you turn on checksums, every block in the database now has a checksum, and every access to that block verifies that the checksum is good. And if it's not, you get an error. So this is particularly helpful for detecting storage corruption. That brings us to the topic of storage. I strongly recommend that you try to make your storage system as simple as possible. The more complicated your storage system is, the more parts of it there are that could be broken in some way. I really recommend local disks. I know that sounds very 1990s or 1980s or sometime that's not now. But there's really no substitute for local disks. You still have a couple of things that can fail. You have a Linux kernel, you have a file system, you have some kind of drive controller, you have the hard drive itself, and all of those components can and do sometimes go wrong. But at least you don't have a network interface card on the local machine and a network interface card on the remote machine and maybe a virtualization layer and some kind of complicated SAN infrastructure. the more complicated you make the storage, the more ways there are for that storage to be unreliable. Yeah, it's a very common scenario, and I've seen a lot of people discover that their SAN does not have the reliability semantics that they think it does. I don't have a solution to that problem because I know that for many people, using the SAN may be mandatory under their company policy. And I can't solve that problem, but I can tell you that that is very often the culprit. People have a crash somewhere in the stack, and they're like, well, I'm using NFS. What's wrong with that? Well, have you configured any of your NFS settings for reliability? Do you even know that there are NFS settings that affect reliability? I've also seen some of those SANs deliver extremely strange behavior that is definitely not per specification and just return completely weird error codes to PostgreSQL and just basically not work in the way that they're supposed to work. So I know this is a problem. I don't have a solution to it. People who use local disks experience much better reliability than people who are going through something like NFS or iSCSI, particularly if they're not very familiar with how to set up NFS or iSCSI and you don't consider what exact settings they should be using there. I recommend you use RAID. Don't rely on it not to fail, because this whole talk, in a certain sense, is about failure. Every component fails at least some of the time, right? And the way that you get reliability is by having as few components as you can and making those components as reliable individually as you can and hoping that somewhere along the line you're able to intercept the problem before it causes you a really serious issue. You still need backups, even if you're using RAID. You still need to do these other things to test for corruption. But one of the most common pieces of a server that fails, in my experience, is the disk. If you use RAID 10, you can get some nice performance benefits out of that. And if one of your disks fails, you'll have a second disk with the same contents, which is a really nice situation to be in if you experience some kind of data corruption issue. You determine one of the drives is bad, pull it out. Everything still works, and you have your data. I recommend a lot of caution when choosing a file system. ext4 is the default on most Linux systems these days, it seems, and that's a good default. ext4 has, in my experience, proven to be very reliable. I also have not heard any reports of trouble with XFS. I think that's generally quite reliable as well. The other Linux file systems that are out there and some of the other file systems that people use on some of the other systems have been more questionable. And I know someone is about to get very, very angry at what I'm about to say, and I'm sorry, but I have not had good experiences with ZFS. I know a lot of people love it, but I've had multiple people have very, very serious corruption problems that cannot be explained by anything other than a ZFS bug, or maybe several ZFS bugs. The more you choose a file system that lots and lots of people are using, the better your chances are that it has been thoroughly debugged. There are lots of file systems out there for Linux, and many of them probably have very cool features that you might not get with ext4 or XFS. But the fact that these file systems are so well debugged is a huge benefit to you if you're trying to avoid corruption. I have yet to see anybody using either of those file systems have a corruption problem that can be attributed back to the file system. And I think pretty much every other file system I've heard of somebody using, I have. So take that for what it's worth. The other thing you really need to do in regard to your storage is monitor your logs. You need to monitor both your PostgreSQL logs and your operating system logs. If your storage returns an error to PostgreSQL, like IO error, PostgreSQL is going to log that. You want to notice that you've got log messages showing up in your PostgreSQL log file that say IO error. That's not something that you want to miss. But even if nothing gets reported to PostgreSQL, there may still be something in the OS log, because many systems do emit some kind of early warning that says, well, I'm not failing yet, but things are not going well. You want to notice those kinds of messages or any hard failures that are showing up in your operating system logs. Again, the goal here is to intercept the problem early. So finally, with regard to administration, I almost feel very silly putting this first bullet point on the slide, but experience has taught me that it is an absolutely necessary caveat. You cannot just go in to the PostgreSQL data directory and randomly modify, let alone remove, files. And people do it all the time. They go into the PG wall directory and they're like, well, some of these wall files look like they're pretty old. Or maybe all of them look like they're pretty old. I think I'll just remove them, right? Well, what you have to understand is that every file in the PostgreSQL data directory, except for a couple of text configuration files like postgresql.conf and pghba.conf, is intended to be managed by the system. PostgreSQL wants those wall log files gone just as much as you do. And it has concluded that it would be unsafe to remove them. If it thought it were safe to remove them, they'd already be gone, right? So you need to log into your database, look at your database logs, and figure out why the database thinks it still needs all of those files. Not just decide that you know better than the database and you can remove them. If you remove them, you will have a very fast trip to the Department of Corruption. The problem is even worse if you decide to remove the files from PGXact or PGClog. People who know what those files do in the room are probably laughing, but it's very bad if you remove those files, and it's happened countless times. In fact, one of the reasons why these directories got renamed from the old names of PGXlog and PGClog to the new names of PGWall and PGXact is because the PostgreSQL developers were hoping that if we didn't have log anywhere in the file name, people would be less likely to think that this was something that they could just blow away. Regardless, don't blow away any files in the data directory. You need to get the database to blow away the stuff you don't want to be there anymore. You can't do it yourself. Also, don't modify files. Part of this is don't run antivirus software. If you absolutely have to run antivirus software on the machine where you're running your PostgreSQL database, at the very least, exclude the PostgreSQL data directory. However, we have found that some virus scanners don't really pay attention when you tell them to ignore certain directories. And when you think about it, the whole purpose of a virus scanner is to run around and change your files in a way that you didn't ask for. It removes viruses from files. That means it modifies the files. It quarantines files. It deletes files. It's making changes to your data. You do not want anything except for PostgreSQL to make changes to your PostgreSQL data files. PostgreSQL will not cope with that. You will end up with a corrupted database. In fact, if you think about it, how does any piece of software cope with some other piece of software randomly deciding to modify its files according to some algorithm that it thinks best? It's crazy that that works at all. Don't remove postmaster.pid. If you do, you might end up circumventing the checks that prevent multiple copies of the postmaster from running on the same data directory at the same time. If you manage to get multiple copies of the postmaster running on the same data directory at the same time, congratulations. You're a very clever person, and also you just corrupted your database. Test all of this stuff. Everything we just talked about on all of these slides, test it. Make sure it works. Rip the plug out. When the system comes back up, see if the database looks okay. If it does, do it a few more times. See if it works reliably. Do it when the database is under load. If the database is idle and you rip the plug out, probably nothing's going to happen. But if you're running your workload at full tilt, that's another story. Obviously, do not do this with your production database. Do it on your test instance. Okay, so if our attempts to avoid corruption fail, and corruption happens, what do we see? What is the thing that we experience as a result of that having happened? Typically what people see, or at least what they complain about that eventually makes its way to me, is strange errors. I'll give some examples in a minute. Not all database corruption causes errors. but it's pretty common, especially if the database corruption is serious. And unfortunately, there's a hugely wide variety of errors that are possible depending on exactly what has gone wrong. But generally, be on the lookout for errors which seem to be complaining about things internal to the database system as opposed to user-facing things. So, for example, if you see an error in your log saying, inserting this row would be a foreign key violation, that is not an indication of corruption. That's an indication that somebody tried to insert a row that violates the foreign key constraint, and there's no real problem there. If you see errors like this that are complaining about things internal to the system, like being able to access the status of a transaction, or being unable to open a file that's managed by the database, or some problem inside this index where we can't re-find the parent key, whatever that means. We don't know what that means, right? That doesn't seem like it should logically be something that is the result of something that a user did. That's the database complaining about some unexpected problem internal to itself. So that may very well be a symptom of corruption. This one here, cache lookup failed for relation some number, is a super common thing that happens when people's system catalogs are corrupted. So all of these errors, you might not know what they mean, or maybe you do know what they mean, but you can see that they're all sort of complaining about stuff that isn't really normally user visible. It's complaining about some internal thing. If you don't know what these errors mean and you have them, it's a really good time to get a support contract if you don't have one already, because you probably want to talk to someone who does know specifically what these errors mean and what might have caused them to happen, because then they can tell you in more detail exactly what has gone wrong. Sometimes you don't get an error. Sometimes you get a database crash, which seems like it shouldn't happen, but there are a few situations in which it does. You can get wrong answers to queries, maybe depending on whether or not you use an index, the same query returns a different answer. Or you can get infinite loops. Those problems can be very tricky to diagnose. The errors are a little easier because just by looking at the error message, you can usually kind of tell whether, some of these are things that you could have confusion as to, does this represent database corruption or is this just a database bug? That's not always 100% clear. But something's definitely pretty wrong if you start seeing messages showing up like this, complaining about internal things. I actually originally had about 7 slides with different messages that we've actually seen come up, but there just wasn't time to go through that many messages. So let's say you realize your database is corrupted. What do you do? Well, the first thing you do is try everything you possibly can to avoid doing anything else with that corrupted database. So for example, if the problem is just with a standby and the master looks okay, don't try to fix the standby. Throw it out, right? I mean, maybe not the hardware, but at least the database there. Build a new standby, right? After maybe checking your disk hardware or whatever. If the problem is with the master, maybe you should consider restoring from backup. You're all taking backups, right? Everybody's taking backups. Backups are really important. Or maybe the corruption is only on the master and it's not on the standbys. If that's the case, you could fail over to the standby and later rebuild the master at a future time. Or in some cases, people have data in PostgreSQL that originally they replicated from some other system. If that's the case, you might want to just throw away your database and re-replicate the data and start over. You want to look for alternatives to having to try to get your data out of a corrupted database. Because once you have a corrupted database, your data is corrupted. You may be able to get most of it back. You may be able to get all of it back, but it's really hard to be 100% certain that all of that data is actually still good and that you don't have any lingering problems which are going to cause you trouble later. So, a lot of people, they plunge into corruption and they're like, how do I fix it? And the first answer to that question is, you don't. You do something else, if there's any alternative. But what if that's not the case? What if your only copy of your critical data is in a database that is corrupted, or all of your copies are corrupted, all your backups are corrupted, all your standbys are corrupted? The only choice is to try to recover data from a corrupted database. Well, first of all, please be really careful about this. I'm about to tell you what I recommend that you do about this, but this recommendation comes with no guarantees. It is at your own risk. You may lose your data. Please do not blame me. I will tell you, I told you before, this is very risky. Exercise a lot of caution. The general approach that I recommend, based on my experience, if you have to do this, is, first of all, before you do anything, make a copy of the database. Copy all the files, because you are potentially going to be doing things that make it worse. So if that doesn't pan out, you'd like to at least back up to where you be able to back up to where you were before. Copy it all. Secondly, don't try to just put the damaged database back into service. Your goal should be to use pgdump to back up all the contents of the database, restore them into a fresh database created by a new initDB, and go from there. Because if you just try to repair the database you've got, it may look like you've succeeded, but there may be hidden problems that are actually going to come back and bite you later, right? And without getting into the exact nature of what some of those things are, some of those are things that can take months or years to crop up. And then all of a sudden, 2 years after you fixed the corruption, you're getting a strange error. How did that happen? So the basic procedure is backup, pgdump, restore into a fresh database. But it doesn't always go smoothly. Sometimes, in order to run pgdump, you have to be able to start the database. What happens if you can't? There is a tool called pgwall or Reset ExLog that will often make your corrupted database start. It does not make your corrupted database not corrupted. It might make it more corrupted than it was before. It makes it start, okay? And that's sometimes what you need. This is typically your only option if the necessary wall files have been lost or corrupted and can't be recovered, or similarly for PG control. In other cases, it's more iffy. You might want to consult with someone who's familiar with these topics. But it does try very hard to make it start. Not to make it good, make it start. If the database is so badly corrupted that there is no hope of starting it, you should have a look at the open source PG file dump utility. It's not part of PostgreSQL itself. It's another project. Tom Lane maintained it for years when he was at Red Hat. There's now other people maintaining it. And it has the ability in newer versions to recover data from the raw data files without needing to start the server. So if you're in a situation where most of your database has been blown up and you have a few files and you want to try to extract what data you can from those files, that tool may be of help. But let's suppose we manage to start the database and then we still can't run pgdump. This is an extremely common scenario. pgdump is designed to work on uncorrupted databases. It has sanity checks in it. When you try to use it on a corrupted database, those sanity checks may fail. You have to work around that problem to be able to run pgdump so that you can get your data out. If it's failing due to a problem with a specific object, one approach you can consider is just dropping that object, especially if that object is something like an index or a temporary table that is maybe not so critical. Another thing you can do in the case of indexes is re-index. You won't be able to drop system indexes, so if you have a corrupt system index, re-indexing it is often a good way to overcome that problem. If you can't dump the whole database, maybe you can dump individual tables or schemas so that you can at least get something out of it. If you can't dump a particular table, you might be able to get at least some of the data out of that table by using a select statement with some kind of where clause. If pgdump is failing to dump the whole table, select without a where clause is probably also going to fail due to exactly the same reasons. But you might be able to select a subset of the data in your table. There's a hidden column called CTID, which is the physical position of the tuple within the table. So filtering on that can be helpful by saying, please give me the tuples that are not that one over there. which might be the problematic one. Enterprise DB also has a utility called PGCatCheck, which I found very useful in situations like this. In fact, we wrote it because of situations like this. When you do have corruption in your system catalogs, PGCatCheck can very quickly give you a very accurate idea of what the problems are and how widespread they are, which may help you to design an appropriate recovery strategy. This is not, PGCatCheck is not part of PostgreSQL. It's in the Enterprise DB GitHub repository. And typically, if we have a customer who has this kind of problem and they contact us for support, we'll say, could you download this tool, compile it, run it on your server, and then we'll be able to give you further instructions. I don't know whether other people will like it. I love it. I designed it, so that might be why I love it. But it tells me what I want to know about how your system catalogs are corrupted. Whether that's what you want to know, that's another question. So the last way that things can go wrong is maybe you're able to start the database just fine. Maybe you manage to run pgdump without any problems. Maybe that all works the first time, or maybe after you beat it using some of the techniques that I just described, or other techniques with which you may be familiar, you finally manage to get a dump. And then you're like, yay, all my problems are solved. So you go and you try to restore the dump into a new database, and it fails. And you're like, what? I converted my data into text format. How can I still have corruption? Well, you can still have logical corruption. Maybe your database was corrupted in such a way that a column that had a unique index on it ended up with duplicates. Shouldn't happen, right? But in a corrupted database, who knows? Or maybe you ended up with some foreign key violations in the database that shouldn't occur. Those things won't prevent the data from being backed up by pgdump, but they will prevent you from restoring that dump on the proper schema. There's no automatic solution to that problem. A human being has to look at the data and decide what to do. For example, if you have a duplicate row, you could merge the two rows, or you could delete one of them, or you could decide to drop the unique index off of that table and load them both, or whatever you want, right? But you're going to need to decide that based on your business logic. A human being is going to need to examine that and say, I know something about what this data is actually supposed to mean, so I can make a judgment as to what the best thing to do is in this particular situation. And that's the end. Thanks a lot. I think are we out of time? I think we're out of time. 5 minutes. Okay, so I can take a couple of questions. Yes?
I have 1 terabyte of database, Postgres, and then it is taking 6 hours just to do the backup. And I have not yet tried that it's being recovered or not. So, restored or not. So, is there any way to improve the time? Is there any way to improve the time of backup, which is right now 6 hours for 1 terabyte of DB?
Yeah. So people who are trying to back up larger databases often have pain. So some of the backup tools that are out there for Postgres today have parallel and incremental backup functionality built into the backup tool. So you might want to check into those. I think PG Backrest has some stuff. I'm not sure about Rep Manager or Barman. And EDB's BART has that capability built into it as well. We're actually working, Enterprise DB is working with some other people in the community to try to get parallel and incremental backup functionality into PostgreSQL Core, which I think will provide some relief for people in your situation. But that's probably going to be a little while before we get all that engineering work done.
I have a database which is having 4 terabytes of size. And
I can't understand.
I have a 4 terabytes sized database with a replication server.
Okay.
I used to take another copy of the database by running rsync on that. So after completing the rsync, when I try to start Postgres, it starts okay. But all the indexes are corrupted.
Yeah.
I have to drop it and rebuild the index. Is there a solution for that?
Yeah, don't do that. That's exactly what I mean about user error, right? There's a procedure for backing up a running database, and it's not that. You just invented that, right? It's not what the documentation says to do, and it doesn't work, and reindexing is only fixing a small portion of what's wrong with that database, and you're very likely to have very serious problems at a later time if you proceed in that way. Okay, if it's stopped, then it should work. Okay, I don't know why that's happening. One thing that sometimes causes indexes to get corrupted is if you copy the stop database cluster and you move it to a different machine with a different and incompatible version of libc on it, because the collations will be different, and so the index on the text column may look out of order. If it's not that, I don't know. I don't think we can diagnose your particular database corruption problem on the fly right now, but something's wrong. If you stop the database first, then I take it all back. That is safe. It should work, and something else is going on.
Bob, so we have about 12 to 14 instances backed by about 3,000 terabytes of data, which is all of it is on SAN. No NFS, no iSCSI, pure SAN, powered by Brocade Gen 6, which is, and backend is flash storage. So I was just keen to understand what, we have not faced any corruption as yet, but we're keen to understand what was that, why you had reservations about, running PostgreSQL on SAN, because some of our PG12 instances, we have even containerized them. So
yeah,
we
so
haven't had any issues.
the best thing I can say is test. Test, 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 right? I know a lot about Postgres, or at least I try to know a lot about Postgres. I don't know anything about your SAN or anyone else's SAN. I can't tell you how reliable your SAN is, right? But I can tell you that if you do testing, right, if you deliberately crash the database, or not the database, but the whole operating system or the whole SAN, and then you bring it back up and you look whether you have the kinds of corruption problems that he was talking about, like your indexes being bad, or foreign keys being violated, or duplicate keys being violated, you can run your workload on that database, crash it, and see what happens. If you don't get corruption, that's a pretty good sign. It doesn't prove things are good, but it's definitely an indicator. Yeah, I mean, there's so many variations in the hardware and software that people have. It's like there's no general guidance that I can give you that makes it absolutely sure that you're safe. You have to test your own environment. And I know that's a lot of work, and it's disruption, and it might impact uptime, and it's hard, so people take their chances, and that's fine. They totally have the right to do that. But if you really want to make it a priority to make sure you don't get corruption, you have to test the kinds of scenarios that could cause corruption, which more than anything else is an operating system crash or a storage crash. Those are the things that's when you really tend to find out whether or not your storage is reliable, right? And if you wait for it to happen, then you'll find out at that time whether it's likely to cause any problems. If you do it 5 times and it works fine all 5 times and you don't get any corruption, it doesn't prove that you won't get corruption at a later time, but it suggests you're probably okay. If it gets corrupted the first time that you try a test, that tells you something for sure, right? I think.
Okay.
Okay, go ahead.
In the beginning of your talk, you recommended to turn on the checksums. Checksums. So why are they not turned on by default?
They have a small performance overhead.
So what is the overhead?
It depends on your workload. If your database is small enough that it fits in shared buffers, the performance impact is very small. If your database is bigger, then the impact is somewhat more. I think it's a few percent. It's not huge, but it's definitely something. I think people have constructed like cases where it's like a 10% regression with exactly the right workload. It's not typically going to be that high in more normal cases.
Is it possible to have that checksum enabled on some backups and like on some of it? Okay.
The checksum is a property of the database cluster.
Oh.
So it's
Okay.
the whole thing.
So taking a backup from, say, RDS and then restoring it to EDB, right? Say, taking a backup database, PG dump from RDS, AWS RDS, and then restoring it to the EDB. Do we have to look at anything, any particular
That question is an interesting question, but it's not really related to the talk, so
Okay.
we can talk about that afterward.
Okay.
Yeah, so we sometime back faced an issue with the corruption where it said some XYZ block is affected in the file 123, let's say. Okay, so it was clear that that particular page is affected, sorry, file is affected. So my standby was working fine, so I promoted it, everything went well. But I have one question, so I did not try this method, I just wanted to understand if my standby is working fine, there's no corruption, and my master is corrupted, and I know which particular file is affected. So will it make sense and will it work if I simply copy that particular file from standby to master and restart my Postgres? Okay, got it.
Thank you. I think we're out of time now.
Yeah, I think we're out of time. I'll hang around if people want to ask more questions.
Yeah.